how it is that having a bunch of particles, maybe they're point particles even, that are sort of more or less held together by some sort of electromagnetic forces, can end up being a stone or a planet and move as a body which has a center of mass and so on. I mean, that idea, things be made up out of particles, that's an old one, and even the Greeks, had atomistic views along those lines. They didn't really have the right account of how the atoms are held together, but they had a picture like that. That we can see pretty easily. On the other hand, intentionality and consciousness, that's much more difficult to say. You'll be happy to know I won't be saying anything more about that, but I think some other people, this workshop will. The problem actually is very much more difficult, even for ordinary physical things, once one takes seriously the fundamental physical theories that have been proposed in physics. Especially this is so about quantum mechanics, where if you start taking it very seriously, what people seem to say, you wonder how in the world can the world emerge from all of this. And I'm not going to go down that line either very far, because I think we have a lot of time talking about that. But, here's the kind of thing I mean. So Newtonian physics, for example, is a fact about the macro world. Planets, comets, and so on move in more or less elliptical orbits. But we want to understand why that's so. We want to say, what are planets? What are they made up out of? Can a kind of classical mechanical view give an account of that? Well, of course, in the end, it can't, because it's not right. But we can sort of get a picture of how bodies can be made up out of smaller parts, and how they move, and why they move in a more or less elliptical orbits on the basis of the Newtonian laws. Well, they're not quite right, but there's a better understanding of that in terms of general relativity and so on. I mean, here's one which isn't much discussed by philosophers, though it's widely known, I guess. Metaphysicians like to give, when they're talking about intrinsic properties, one of the main examples they give is shape. I mean, if shape isn't intrinsic, what is it? But anyone who knows just the beginnings of special relativity knows shape is not intrinsic, not an intrinsic property. But it seems to us to be an intrinsic property. So in the Decrying project, we want to understand, what is it to be an intrinsic property, and why is it that shape at a moment seems to be an intrinsic property when in fact it really isn't? So part of the Decrying business can not explain why some macro commonplace is true, but actually explain that it's false, but why it seems to be true. And one of the more interesting ones over here is in quantum mechanics. Again, I'm not going to go into a big discussion of this, but is one of the views that's on the table, that's discussed a lot, is Everett's many worlds version of quantum mechanics. And actually it says, in some sense, that everything happens that is compatible with quantum mechanical description of a state. And as the state evolves, it seems to sort of bunch up into different worlds, worlds that are even reminiscent of possible worlds. Semantics. There's a guy at Oxford who's really taking this comparison very seriously. Somebody I know pretty well. At any rate, if that's right, why does it seem to be that there's just one world? Well, Everett, the inventor of many worlds of quantum mechanics, was sensitive to this question, and he argues, he has an argument that, well, if he was right, and all the time the worlds are splitting into many, many worlds, it would still seem to occupants, conscious occupants like us of any world, that there was no splitting occurring. And the physics itself explains that. Just like, and he makes this analogy, just like the physics explains why it is that we don't feel the Earth moving, when in fact, as Galileo says, okay, you get the Decrying project, big project, last many lifetimes, you do it well or badly. We're into that. David and I will do a seminar on this in the spring, next spring. There are hard problems for the Decrying project. Here's some examples. The philosophically very sexy-sounding ones are the, really ones that interest a lot of philosophers. How does normativity fit into this picture? How does mentality, consciousness, and intentionality fit in? So-called experiential properties, like so on. The one of these that I'm very interested in is time's arrow, the distinction between future and past. Now, many people who think of themselves as physicalists just accept that there's a distinction between past and future and a direction of time's arrow. And they also accept that there's causation as just basically, doesn't physics give us that? And the answer is no. Physics does not in any obvious way give us time's arrow or causation. Causation is not a fundamental feature of physics in an obvious way. There's a lot of discussion that takes place here, but I would still echo, it's now about 100 years ago, Russell's famous remark, which I didn't think of saying beforehand, even though I made it many times, so I'm not going to say it exactly right, but Bertrand Russell said something like, philosophers and we all should dispense with the concept of causation, because causation is like the royal monarchy. It's kept around because it's erroneously thought to do no harm. Well, Russell went too far. I think we need it. But it's not fundamental, and it's not quite what it appears to be. It's something like intrinsic. That's the same intrinsic property is. And there'd be nothing in the world that quite plays the role of causation. Why? Well, because when you take the kinds of theories that I was talking about before, it's fundamental theories that have been proposed, you don't find causation as a fundamental feature in those theories, I claim. Okay, well, when you look at classical mechanics, and the same happens when you look at quantum mechanics, differences, important differences, of course, and when you look at what might be quantum field theory, or whatever the future gravitational quantum theory is going to be like, there are some features which seem persisting through it, and I'm going to sort of work with that idea. That fundamental physics is not going to solve the time's arrow problem on its own. The way it's given on its own right now. It's going to need something else. So there were two hard problems for physics, in any way, at the time that Mach was writing and the time that Boltzmann was writing. Everybody here, in fact some people here probably know a whole lot more about Mach and Boltzmann than I know. But I know they were not friends, and that Boltzmann thought that Mach was ruining his career all the time, that they really disagreed about atomism a lot, and realism. And as you'll see, I guess I'm going to give this away, in writing this and thinking about this, and I would never have thought about this without this occasion, I came to see that although I'm on the Boltzmann side, as you'll see in a minute, especially about the atomism stuff and the realism about science, that for Boltzmann's way of thinking about things to really work, you need a kind of Machian view about laws. I don't need. The Machian view about laws makes more sense. So I kind of coming to you as a reconciliationist, reconciling these two guys buried in their graves, enemies of life. So it's pretty good thing. Okay, so here are the two hard problems for physics. One of them was widely realized at the time of Mach and Boltzmann. It was the problem that, along with the development of classical mechanics in the hands of people like Hamilton and Maxwell and so on, and the development of electromagnetic theory, was developed a kind of macro science of thermodynamics. And thermodynamics, science of heat engines, is the way it was introduced when I took it in school. And people began to realize that they don't fit together so well. Classical mechanics is temporally symmetric in the sense that if there's a sequence of states, positions and momentum, that are compatible with the Newtonian dynamical laws, which remember are in a sense are complete and deterministic, then there's a temporally reversed sequence that's also compatible. And there are just as many, in any sense of many, of one as the other. Sometimes this is illustrated, and I had, my son's very clever with videos, but I didn't really put this in right, so I just want to imagine this. Everybody has seen this. You take a film of a diver diving off a diving board and landing in the water, right? You can run that film backwards, and the diver is ejected from the water, the splashes go down, and the diver ends up on the diving board. And